today is gonna be the day that they're gonna throw it back to you. By now you should have somehow realized what you gotta do. I don't believe that anybody feels the way I do about you now.
Okay, we're on to section 2.6. It's called the chain rule. It's an extremely important rule. You're going to use this many times. It can be confusing at first, but you'll use it so many times that you're going to get good at this. So, chain rule has to do with composite functions, taking the derivative of composite functions. So, just one quick example to remind you what a composite function is. If we have two functions, one's f of x and it's equal to the square root of x, and the other function's g of x, which is equal to 3x plus 1. And I want to know what's f of g of x, which is the same thing as f of g of x. Remember the fog x? Okay, so I'm asking what's f of g of x. So the way you solve this, whether it's written like this or like this, is you take the g of x and you plug it into f, right? You take g of x, this amount, well here's g of x right there, and you plug that in to there, into the f of x. So basically what you would get is the square root of, and where you see x, you're putting 3x plus 1. You're putting the g of x into the f. Sorry, I'm saying it over and over. Okay, so that's what the composite function is of f of g of x. So the question is, what's the derivative of that? What's the derivative of this right here? Which rule are you going to use for that? We can't do it right now. Can't do it. We're not able to do composite functions yet. So this is why we're going to introduce the chain rule to you, because the chain rule will help us to differentiate composite functions. So here we go. Given the composite function h of x equals f of g of x, where f of x and g of x are differentiable functions, the derivative of h of x equals f prime g of x times g prime of x. Wow, what does this mean exactly? So basically, what you need to be clear for these composite functions, like let's go back to this one again. What you need to be clear about is that there's an outer function and there's an inner function. So with this right here, what's the inner function first of all? The inner function is the 3x plus 1. I'm actually going to write this in here. This is the inner function. And as my wonderful old colleague, Mr. Habibian, who hates so much when I make up things like Bobby Bridge and Spread the Love, he hated that so much. But it's he who named this the kernel. Okay, it was him who named this. Even though it's not a math term, he came up with it, not me. So the inner function is called the kernel. That's what Mr. Habibian calls it, the kernel. But that's your inner function right there. What's the outer function? The outer function, I'm not really sure how I'm going to be able to show this. I can do it like this. The outer function is this. That is the outer function. I'll do it in green to make it connect. This is the outer function. And what Mr. Habibian calls that is the shell. Okay, so with that in mind, here's what we're going to do. You're going to take the derivative of f. Is f the outer or the inner? F is the outer, right? F of x is the square root, and we said that square root is the outer function. So you're going to take the derivative of the outer function, which Mr. Habibian calls the shell, take the derivative of the outer function, the shell, leaving the trapped inner function, the kernel, alone. And then after that, what you're going to do is you're going to take the derivative of the inner function, the kernel, and you're going to multiply those two things together. This is why it's called the chain rule, because you're chaining together the derivatives. You're chaining them together by multiplying them, right? You're going to get a chain of derivatives. Okay, so let's do the same one that we're just talking about, the square root of 3x plus 1. Let's actually do this now. So the first thing is that we want to rewrite this. We want to have the square root sign here. What might be an easier way to write that? We're going to write 3x plus 1 all raised to, since it's all the square root, it's all raised to the 1/2. Okay, so our outer function is the 1/2. That's our shell, if you want. The inner function is the 3x plus 1. That's the kernel. So the first thing you're going to do is you're going to take the derivative of the outer function. The something doesn't, regardless of what the inner function is, you have something raised to the 1/2 power. So what do you do when you have something raised to the 1/2 power? So we want to get the derivative. We have something to the 1/2 power. When you have something raised to the 1/2 power, you use the power law. The 1/2 comes down. The something stays exactly the same. You don't do anything to that inner function yet. And the power law says what you're going to do to this exponent is you're going to lower it by 1. So it was 1/2, now it's going to go to negative 1/2. So that's it. We've done the derivative of the outer function. Now what we do is we chain it up by multiplying with the derivative of the inner function. So now we look at the inner function and we ask ourselves, what's the derivative of that? Just the 3x plus 1. And the derivative of 3x plus 1 is just 3, because the derivative of 3x is 3, and this is a constant, which is just 0, so we don't put it down. So this is our answer. Now we just have to simplify. So what do we have in the numerator? This is a numerator, and the 3 is a numerator. 1 times 3 is 3. What do we have in the denominator? We have a 2, and then we have all of this to the negative 1/2. Well, the negative mean it flips down into the denominator, and the 1/2 means square root. And what's still left inside is a 3x plus 1. So this is your answer. Okay, this will take a little bit to get used to, but you got to get used to it. The chain rule comes up over and over and over. Okay, here's another one. If y equals x squared minus x plus 2, all raised to the 8th power, find dy dx. Of course, dy dx means find the derivative. So the first thing, again, you want to get clear of is what's the outer function, what's the inner function. So what's the outer function? The outer function is something raised to the 8th power. So this is the outer function, or the shell. The inner function is the x squared minus x plus 2. This is the inner function, or the kernel. So how do we get the derivative? dy dx. We take the derivative of the outer function first. So the outer function is something to the 8th power. How do we take the derivative of that? Well, the power rule tells us that we would move the 8 to the front. We'd leave the something, in this case the x squared minus x plus 2, we'd leave it exactly the same, x squared minus x plus 2, and this 8 would go down to a 7. Now we have to multiply by the derivative of the inner function. So we just look at the inner function. All we're looking at now is this, and you want to write down what's the derivative of that. So the first term would be 2x, the second term would be minus 1, and the third term would be 0. You don't need to put it. So this is it. I don't even think there's really any simplifying you could do here. You're not going to raise this to the 7th power. So yeah, I would just leave it right like that. We're finished. Okay, moving on. Differentiate this. So, you could expand this, but who wants to do that and have to multiply it by itself 6 times? So we'll use the chain rule. What's the outer function here? The outer function is something to the 6th power. So that's the outer. What's the inner function? The inner function is all of this inside the bracket. 2t minus 1 all over t plus 2. That's all the inner function. So let's find s prime. Let's find the derivative. So outer function first. We have something to the 6th power. When you have something to the 6th power, the power rule tells you the 6 moves down, the something stays exactly the same, and the 6 goes to a 5. Now, we're going to multiply that by the derivative of the inner function. Now, what do you notice about the inner function that's a bit of a drag? How are you going to get the derivative of the inner function? You're going to have to use the quotient rule. So allow me to remind you of the quotient rule. Y prime equals f prime g minus fg prime all over g squared, where your f is the top and your g is the bottom. Hopefully you remember this from last day. So f prime, we got to take the derivative of the top. Well, the derivative of the numerator is just 2. And we multiply that by the bottom, g, which is t plus 2, minus f. The f is just 2t minus 1, and we're multiplying that by the derivative of the denominator. Well, the derivative of the denominator is just 1. This is all divided by g squared, so that's t plus 2 all squared. Okay, let's simplify. So I don't think for now we should do anything at the start here. Let's just leave all this. The part we can simplify is this bit, because we can expand here, expand that negative 1 there, and we'll see what we can combine. So we have times, remember this is times, 2t plus 4, and then minus 2t, and plus 1. Negative 1 is plus 1, all over t plus 2 squared. So I think we can cancel out, what, 2t and negative 2t. So what we're left with is 6 2t minus 1 over t plus 2, all raised to the 5th power. And then we have 4 plus 1 is 5 over t plus 2 squared. And remember, multiplying. Okay, you can actually simplify this even a little more. You've got a 6 here and a 5 here, and you're multiplying. So obviously you're going to have 30 on top. Now, do you notice one other thing? You have a t plus 2 here and a t plus 2 here. Now, this 5 here, remember, can apply to the numerator, so it's 2t minus 1 to the 5th power. And I think we should actually write that. 2t minus 1 to the 5th power. And on the bottom, I guess I could do this in 2 steps. You have t plus 2 to the 5th power, and you also have t plus 2 to the 2nd power, which means our final answer will be that 30, the 2t minus 1 to the 5th power, but you have t plus 2 to the 5th and t plus 2 squared. Hey, same base. What can you do when you're multiplying? You add the exponents. So it's all over t plus 2 to the 7th power. That is your answer. Now remember, what we found is we found the slope of the tangent line for any point if we were to graph this curve, or we found the instantaneous rate of change. That's what derivatives are all about. You really want to keep that in mind. Okay, this last question is a bit of a doozy, so here we go. So you kind of have two parts to this. You have the x squared plus 1 cubed, and you have the 2 minus 3x to the 4th power. So what's the first rule you should actually think about here? The first rule you should think about is the product rule. You're actually multiplying those two things together. So you have like your f and your g. Remember, the product rule is f prime of x is equal to f prime g plus fg prime. So that's what we're going to do. Now, why is this in this section? Because when I go to take f prime, when I go to take the derivative of this, what rule do we have to now use to take the derivative of f? We have to use the chain rule, right? In order to get the derivative of x squared plus 1 cubed, we have to take the chain rule. So the outer function is something cubed. How do you get the derivative of something cubed? You move the 3 down, you keep the x squared plus 1 the way it was, and the 3 drops down to a 2. Now, we're not finished f prime, right? Now we have to do the inner function. So the inner function is just the x squared plus 1. What's the derivative of x squared plus 1? 2x. This is just 0, so 2x. So we have to multiply that by 2x. That's our chain rule. We're chaining those two things together. Okay, all we've done there is just f prime. This is f prime. Now we have to multiply it by the g. Well, g is 2 minus 3x to the 4th power, plus f. f is x squared plus 1 cubed. G prime. Okay, again, when we get the derivative of g prime, you have to use the chain rule again. We have something to the 4th power. That's your outer function. Something to the 4th power. Well, power rule tells us that the 4 moved down, the 2 minus 3x stays the same, and the 4 drops down to the 3. Now you have to multiply by the derivative of the inner function. So what we're talking about right now is just this, right? We've got to get the derivative of that. So the derivative of 2 is 0, so don't have to worry about that. And the derivative of negative 3x is negative 3. Oh boy, we have some simplifying to do here. Okay, often this will happen with questions like this. You see how you have x squared plus 1 squared here and x squared plus 1 cubed there. And you also have 2 minus 3x to the fourth here and 2 minus 3x to the third here. So chances are you're going to be able to factor out a bunch of these things. Don't expand those things. Okay, it's going to be way too much work. You might make the mistake of doing that once or twice when you first see these, but after a while you'll realize to spot these and just leave them. So in this first bit, from here to here, what can we multiply together? We can multiply the 3 and the 2x together. So let's do that. We get 6x, and we're going to leave the rest here not expanded. Just leave it in factored form, I guess. So we have the x squared plus 1 squared, and we have the 2 minus 3x to the fourth power. Okay, now let's look at this. What can we multiply together here? The 4 and the negative 3. So we get negative 12, and we have x squared plus 1 cubed. I know it's hard to see, but that's a 3. And we have 2 minus 3x cubed. Okay, we're going to factor here, and we're going to factor, same thing if I look at these red lines, the same bit, and this bit, these two bits. What can we take out of each one of those two parts? Let's start by looking at the 6x and the negative 12. What's the greatest common factor of 6x and negative 12? Greatest common factor is 6. Now, let's look at the next part. X squared plus 1 squared and x squared plus 1 cubed. What can you take out of both of them? You can take out an x squared plus 1 squared, right? We can take 2 out of here, and we can certainly take 2 out of here. But you couldn't take 3 out of here, so that's where you're stuck with the smaller exponent. Okay, similarly for the next part, you can take out a 2 minus 3x to what power? 3. We take the smallest exponent again, so 3. So this is our greatest common factor. Then what you have to do, as you always do when you take out a greatest common factor, is you ask yourself, what do I have to multiply all this by in order to get this first bit, this first red line here? Well, the 6 needs to multiply by an x squared plus 1 squared, we already have that, but we only have 3 2 minus 3x's. You need 4, so you're going to have to multiply by another 2 minus 3x. Great. Now we look at the second red line. What do we have to multiply 6 by to get negative 12? Negative 2. What do we have to multiply x squared plus 1 squared by to get x squared plus 1 cubed? We need to multiply by another x squared plus 1. 2 minus 3x cubed, 2 minus 3x cubed. Great, we already have enough of that. So this is complete. Now, the greatest common factor part, just leave it. Do not expand it out. This is nice factored form. We're just going to leave it exactly the way it was. But for the part that's left over in here, we can expand it and combine some terms. X times 2 is 2x. X times negative 3x is negative 3x squared. Negative 2 times x squared is negative 2x squared. And negative 2 times 1 is negative 2. And again, we're just going to leave these first things alone. Squared 2 minus 3x cubed. Let's see what we can combine. Let's put them in descending order. So we have negative 3x squared and negative 2x squared, which is negative 5x squared. We have a 2x, and we have a minus 2. And we're done. Believe it or not, this is the derivative. This is a tough question, but certainly will be questions like this that you're expected to know. So this is the chain rule. I advise you to do all of the homework on this because you really need to get familiar with the chain rule to be successful in the course.
And all the lights that lead us there are blinding. There are many things that I would like to say to